This is sections 9495, day 1. We're going to talk about trigonometry. So trigonometry is the study between the of the relationship between the sides and angles in triangles. And we're going to be focusing on right triangles for our trigonometry. The three main trigonometric ratios, which are sine, cosine, and tangent, can be remembered using SOHCAHTOA. So SOHCAHTOA is listing those three main ratios, sine, cosine, and tangent, and which sides we would be using. So O and H stand for opposite side and hypotenuse. A and H stand for adjacent side and hypotenuse. O and A stand for opposite side and adjacent side. So we're always going to be using sine, cosine, or tangent of a specific angle, one of the acute angles, and we're going to label the sides as opposite, adjacent, and hypotenuse according to that angle. And that's what we say here. Once you know which acute angle you're using, you need to label the sides of the triangle. So H is hypotenuse, the side opposite the angle is O, and the side adjacent to the angle is A. So we're going to label our triangle here using angle A. So they're telling us that the acute angle we want to use is angle A. So the hypotenuse is always opposite the right angle. So if I make an arrow to the right angle, that's our H. And opposite the A, if I look at the opposite side of the triangle from where the A is, that would have been here, BC, or the side that was Y units long. And that leaves the last side to be the adjacent one. That's our A. For sine, I'm going to write my SOHCAHTOA out again. SOHCAHTOA. Sine is going to be O over H. So O over H is Y over Z. For cosine of A, so that's A over H, that's going to be X over Z. And the tangent of A is going to be O over A, so that's Y over X. Here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. For example 2, we're now going to do it with not just variables, but with numbers. But we're still just going to write them as fractions. So this is asking for sine, cosine, and tangent of angle P. So P is the angle I will circle, and I will label. Across from the right angle is our H. Opposite the P is O, and our remaining side is A for adjacent. So the sine of P, O over H, will be 15 over 17. Cosine of P, which is A over H, would be 8 over 17. And tangent of P, which would be O over A, is 15 over 8. If I were to choose angle Q instead of angle P, the O and the A would be switching places. The H wouldn't change because that's always across from the right angle, which means our sine and cosine would switch places. So that's what happens when you use a different acute angle in the picture. The cosine and the sine are going to be the reverse of each other. So here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. Using the calculator. The calculator must be in degree mode, not radian mode. Normal scientific calculators come standard in degree mode, but normal graphing calculators come standard in radian mode. So you will have to change the mode if you are using a graphing calculator. And this includes when you're taking tests like the NJSLA or NJGPA. The ratio of the sides is directly related to how many degrees the angle is, and the buttons on the calculator, the ones that are called SIN for sine, COS for cosine, and TAN for tangent, give you that ratio written as a decimal. So if you know how many degrees an angle is, you can determine the decimal equivalent of the ratio of their sides. So using a calculator, we're going to find each of these to 4 decimal places. So we would just hit the sine button on a calculator and then the 53, and we should get something like 0.79863. So this 3 does not change the 6, so that would be my answer. For cosine of 65, we're going to find the button that says COS, hit that, and then hit the 65. This would be 0.42261, so the 1 will not change the 6. And the last one for tangent of 32, we would get 0.624869. So that 6 is going to change the 8 into a 9 on that one. I just want to note, if you have the TI-34 calculator, you will not have buttons that say SIN, COS, and TAN on it. You're actually going to have to go through some steps to get to those buttons. And I know this is not the actual picture of the calculator, but it does have all the buttons on it. If you notice here above the pi button, it says trig, very tiny. So we would hit second and the pi button to get a list of our trig functions, and we would have to select either sine, cosine, or tangent. This is the only calculator that does not have them directly on it, where you have to go through a menu to get to those buttons. So that's if you have that blue and white TI-34 calculator. There are some check-ins here for you to try. You can pause. Answers are posted on Google Classroom. So for the next example, we're going to be able to find the value of a variable by using the ideas of the buttons on the calculator, knowing what the ratio of the sides should be, and if we label the sides, knowing what the ratio of the sides should be. And by setting those two things equal, we can solve for x. Our first step in these problems is always going to be identify the acute angle we will be using. We were given the 28-degree angle in this picture, so that is the angle I will be using. I have two sides here. I'm only going to label these two because they're the only two I need to solve the problem. So this one is opposite the 28, and this was across from the right angle, making it the hypotenuse. Using our full SOHCAHTOA, I'm looking for which ratio do I have that I can make into my picture. I have an O and I have an H, and I see the O combined with H here, whoops, when it says sine. So we're only going to use sine for this problem because we are not involving the A, and both cosine and tangent involved the A, the adjacent. Now that I know it's going to be sine, I'm going to set up sine of the angle. That's 28 degrees. So sine 28 equals, and if it's O over H, that's going to be X over 19. To get X alone, we would need to get rid of the divided by 19. So we're going to multiply both sides by 19. Essentially, X will be equal to 19 times whatever the sine of 28 is. And I can type this into my calculator using 19 times sine 28, and whatever I get as my answer is it. It's done. So that's going to be 8.919, 8.9. And that's the answer to my question. Let's look at the next one. 41 degrees is my angle. This is O. This side would have been H, meaning this is the adjacent, this is A. So out of SOHCAHTOA, I have an A and an O. For an A and an O, that was right here for tangent. So we're going to set up tangent 41 equals O over A, so that's going to be X over 32. Again, to get rid of the divided by 32, we're going to multiply by 32 on both sides. So X is really equal to 32 times the tangent 41. And typing that into my calculator, I get X equals 27.8. Another one together. My angle this time is 21 degrees. This would have been opposite. This is across from the right angle. That's hypotenuse, leaving this to be my adjacent side. Out of SOHCAHTOA, I now have an A and an H. The A and H, ooh, I didn't think I picked yellow. The A and H combination is there. So we're going to use cosine. We're not going to use sine or tangent for this problem. Cosine 21 equals A over H, so that's going to be X over 26. We're going to get rid of the divided by 26 by multiplying both sides by 26. So x is equal to 26 times the cosine of 21. And on my calculator, I get 24.27, so that'll be 24.3. Here's a check-in for you to try. You can pause. Answers are posted on Google Classroom. Example 5, I have my 33-degree angle. This would be opposite that. This would be adjacent. Here's our hypotenuse. So we're going to use O and H, which is sine. So sine 33 equals O over H. That's going to be 15 over X. So now the number's no longer on the bottom. I have the 15 on top and the X on the bottom. So I can't multiply both sides by 15 this time. What I can do is I can switch, because this is really over 1, I can switch my diagonal parts of my proportion. So really, it's x over 1 is equal to 15 over sine of 33. So sometimes we're going to be dividing to get our answer instead of multiplying. And when we do our division, it's always going to be the regular number divided by the trig angle. So this is going to be 15 divided by sine 33, and I get 27.5 as my answer. So let's look at 5b. Here's my angle. This would be adjacent and hypotenuse. A and H is cosine. Cosine 43 equals A over H, 36 over X. So again, 36 is on top. X will equal, we're going to keep the 36 on top, but we're going to move the cosine of 43 to the bottom, and we're going to type this in my calculator. So X is equal to 49.2. Another example, 72 degrees is my angle. This would be O, this would be H, this is A. So O and A is tangent. Tangent 72 equals O over A, 25 over X. Again, variable on the bottom, we're going to end up making it X equals 25 divided by tangent of 72. And on the calculator, that gives me X equals 8.1. So here's one more for you to try. Pause. Answers are posted on Google Classroom. All right, and this is just a little note for us. If the number was on the bottom, we're going to multiply it by the trig value. If the number is on the top, we're going to divide it by the trig value. So for example 6a, we now have two variables involved. I'm going to start the same way. I'm going to circle my acute angle, and I'm going to label the three sides. The 22 is the hypotenuse, opposite the 37 is x, and y is the adjacent. When I want to solve for x, I'm going to pretend y wasn't there. So I'm going to cover up this side. It's not quite what I wanted to do. Cover it up. Okay. So I can't see this side. That side is not part of my problem right now. I'm only using the O and the H if I want to solve for the x. So that means to solve for x, we're going to use sine. Sine 37 equals O over H, x over 22. This time my number's in the bottom, so we're going to multiply. 22 times sine of 37 is equal to x. And I get x equals 13.2. Now I rounded that answer to get x, so I'm not trusting it as my answer in case I made a mistake or something went wrong. So when I want to solve for y, I'm going to pretend I didn't know what that x was. And now the two sides in my problem are a and h, which means I'm going to use cosine to solve for y. So cosine of 37 equals a over h, that's y over 22. The number's on the bottom, so we're going to do multiplication to solve. 22 times cosine of 37 is equal to y. And I get 17.56, so 17.6. We'll do another one together. I'm going to grab my little Heidi box and drag it to the next problem. Okay, so in this one, the angle I'm using is the 51 degrees. Y would be the hypotenuse. Opposite the 51 is the 14, and x is the adjacent. So again, when I want to solve for x, I'm going to pretend y wasn't there. So I'm only using the O and the A. O and A is tangent. So tangent 51 equals 14 over x because it's O over A. Notice now the number's on the top. So we're going to have to use division. 14 divided by tangent of 51. And on our calculator, that gives us x equals 11.3. And now to solve for y, we're going to pretend x wasn't there. I'm left with an O and an H. O and H is sine. So sine of 51 equals 14 over y. Once again, the number's on the top. So we're going to use division. So 14 divided by sine of 51, y would equal 18.0. So the last problem for you to try is here. There's an x and a y. Answers are posted on Google Classroom, and that is the first day of sections 9.4 and 9.5, our trigonometry.